Inference about two means, independent samples. I keep referring to this as 11.3. Again, that's from a different book. Just ignore that. We are talking inferences about two means, independent samples, independent. Enjoy. Hey folks, chapter 11, section 3, inference about two means, independent samples. So you're going to find that 11.3 is very similar to 11.1. Remember in 11.1, we were comparing two proportions. So now in 11.3, we're just going to be comparing two means. So very similar. Of course, in order to use our new test, what's our new test going to be? So it's clear. It's two sample. And it's all about the X bars and S's and N's. So this is going to be a two sample. Let's come see what it says. Tests, two sample t-test. Two sample t-test. Two sample t-test. And we're also going to use the two sample t interval, two sample t interval. So two sample t int for interval. So those are the two calculator functions we're going to be using in 11.3. Of course, in order to technically use them, the minimum requirements must be met. So if you go to page 548, it goes through the minimum requirements. The samples are obtained using simple random sample or through a completely randomized experiment with two levels of treatment. The samples are independent, and the populations from which the samples are drawn are normally distributed, or the sample sizes are greater than 30. So you'll notice I usually just quickly say something like assume the populations are normally distributed, so that I just don't even have to worry about that. Okay, so let's jump into that first problem. Our first problem, we have, assume the lengths of tuna are normally distributed. See, minimum requirements met. Is the mean length of Pacific tuna smaller than Atlantic tuna? Test at the alpha 0.05 level with the following random sample. Okay, so they give us the sample sizes, that's n. They give us the sample means, that's our x bars, and they give us the sample standard deviations, that is our S. Okay, and then if I'm setting up the problem, usually the first group is group 1, the second group is group 2. Are Pacific tuna smaller than Atlantic tuna? So they sort of talked about them in order. So it's like this is group 1 and this is group 2. So just be careful. If I make the problem, I usually just, the first thing is group 1, the second thing is group 2. But in the homework, just be careful. Sometimes they'll talk about the second group before the first, and you can label them either way. Okay, so very similar to 11.1, I said. So we're going to have a null and our alternative, H1, HA. I like putting HA. H1 is fine. Our book puts H1. Okay, so remember in 11.1, we would say that P1 equals P2. So if this is all about means, it's analogous that our null here is that mu1 is equal to mu2. The means of the different groups are the same. And then the alternative is just we need to figure out what symbol goes there. Less than, greater than, different. Smaller. Less than. Okay. So now they just want us to do the standard 6 questions. So let me just bring it over here. Keep it nice and pretty. We said the null, two groups. We're talking about means. Two groups, talking about means. The null, no difference. Are they the same? And then the alternative was that the first group average length is less than the other group's average length. Test stats. Okay, so let me maybe go back here. We're going to need to throw this all into our calculator. Is this a hypothesis test or a confidence interval? Hypothesis test. So we're going to use the two sample t-test, not int for interval, but test. Okay. Is this raw data or is this summary statistics? This is a bunch of summary statistics, the n, the x bar, the s. Okay, so I'm going to go to two-sample t-test, not interval, two-sample t-test, two-sample t-test. It says data or stats, raw data or summary statistics. Summary statistics, so go to stats, hit enter, and it says, okay, well, what's the x bar for the first group? Okay, so x bar 1, the first group. Careful, I put them out of order here. So the first thing I enter is 35.4. Enter. What's the standard deviation for group 1? What's SX1? 5.8. Enter. And what's the sample size of group 1? 15. Enter. Okay. X bar 2, 38.6. Enter. Standard deviation, 7.9. Enter. Sample size, 12. Enter. Scroll down more. Let's see. Is it the alternative is a less than symbol, so we choose the less than symbol. Enter. Pooled. Always just put no. Don't pool. And then calculate. Hit enter. Ta-da! So it gives us all the information we need. You'll notice the degrees of freedom is really weird and complicated. It's a weird formula. You'll see it in your book on page 551. It's best to just let the calculator do it for us and sort of ignore it. But technically speaking, there is a degrees of freedom. Our test stat, just don't write the number. Write what it is. Z, T, F, it's T. T is equal to negative 1.1729. No reason why I rounded to the fourth, but looks good. Right below it is P. P equals 0.1274. 0.1274. Remember our significance level, it said, let me double check, I think it's 5%. Yep, 0.05. How does this p-val compare to our alpha of 0.05? It's greater than that. If our p-val is greater than our alpha, we do not reject HO. Do not reject HO, which means we're stuck with it. There's not enough evidence to suggest this. Not enough evidence to suggest. And the mu1 is less than mu2. What is mu1? The mean length of Pacific tuna. Not enough evidence to suggest the mean length of Pacific tuna is smaller than the mean length than Atlantic tuna. Being a little wordy here. Than the mean length of Atlantic tuna. Not enough evidence to suggest the mean length of Pacific tuna is smaller than the mean length of Atlantic tuna. Aha, hopefully you're catching on to the game. It's the same thing over and over again. All we really need to know is, hey, which calculator function do I need to use? In other words, what's going on in my null and alternative? Are they talking about one group or are they talking about two groups? Are they talking about proportions or are they talking about means? So that's going to help you figure out which function you need to use. And hopefully that made sense.